Okay, we're in section 27. We just completed the lecture, and now we need to reinforce the material that we gave you in the lecture by doing examples. And the examples we start with are, number one. We're going to start with number one. Again, as I go through this, I want to point out that graphs are being provided for you. Sometimes these graphs are hard to construct. However, you should be able to use the graph to help you set up the problem. All right. So I'm going to switch to the whiteboard and start the problems. All right. So let me do that. I'm going to switch. Okay. So what I want to be clear about is that this thing is providing a graph for me, and I see the graph. Again, if you want to, you can reproduce this graph by using technology, or, basically maybe take points. I need to take points anyway, by the way. And I'll be honest with you. What they want to do is find the length of the loop of the curve. So someone can say, what loop are they talking about? And the loop they're talking about over here is this loop here. So I'm looking at the loop. And again, I'm looking at that loop over here. And they want I have to read that again. What do they want to know? Oh, the length of the loop. It's arc length problem. All right. So before I do that, I just want to discuss the, points on it. And let me write this over here. And this is why, being able to understand a graph is important. All right. So let me write this over here. X, I got to factor that. And that would be, let's see, did I copy that right? Yeah. T, and then you'd have 3 minus t squared. Well, I'm going to say, if I were looking at this thing, I would say, the zeros in the problem for X. Let me write these down for you. So one of them would be, whoops, sorry about that. One of these zeros would occur when t is 0. And the other one would occur at t equals plus or minus root 3. All right. All right, let me keep going. Let's put the y down. So what's y going to be? 3t squared. All right. Well, this does have a 0 when t is 0, right? So y equals 0 when t is 0. All right. So I think I'm going to start at 0 then. All right. So I'm going to start at 0. So if I start at 0, t equals 0, what's the point I'd get? Well, that's pretty simple. I would get 0, comma, 0. All right. I see that point right now. It's right over here. All right. That's certainly in that side, that loop, right? And the loop we're talking about is the loop you're witnessing over there. It's just a loop. Now what I'm going to do is I'm going to say there's probably another place that I should consider. And that's going to be, when t is root 3. I'll put this over here. So when t is root 3. What point would I get there? Well, the x value would still be 0. The y value would be 9. All right, let me put that down for you. That's that point right here, by the way. So this is t equals root 3. This is t equals 0. All right. So what's the point over here? The point here would be 0, comma 9. The point here would be 0, 0. All right. So I'm going to say, kind of looking at that, maybe a connection like this over here. And certainly they're giving me a graph, right? All right. So what did I really get there? I got half of the loop just by looking at that. And so I always say that the limits are the tough guy to figure out, but I have half of a loop. All right. So I'm going to write this down now. So if I have half of the loop between 0 and root 3, I want to double it because I want the length of the entire loop. Then what do you have to do? You'd have to know the arc length formula. All right. So I'm hoping you know that. And I'm going to write that. I'm going to write the formula down for you. So the arc length formula, where x is a function of t and y is also a function, that's a g, by the way, of t. We have the arc length formula. I'll just call it I think in the notes we were calling it uppercase L. I can't really recall exactly, but I think we did. I always said the limits were tough to do, but I got the limits down already. So what's it going to be? It's going to be the root, and we derived this from in class, f prime of t squared. And boy, I'm hoping it's going to be easy for us, plus g prime of t squared, and then we get dt over here. So I got to put these down now, and I'm going to say x is a function of t, and y is also a function of t. No mystery there, it's given. So what's f prime? It's going to be 3 minus 3t squared. What's g prime going to be? 6t. All right, let's write this down. It looks like it might be tough, but I want to encourage you that we don't really ask tough questions. That's relative though, isn't it? So I got to square this 3 minus 3t squared. I'll put that down. And I have to square that 6t, right? All right, I got to do some work over here. And the work is going to be as follows. I got to figure that out. Oh boy, let's see what we get. I'm doing the integrand now. 9, and I'm doing a radicand of the integrand. So it's going to be 9 minus, what's going to be, let's see, minus 18t squared plus 9t squared plus 36t squared. All right, let's keep going. What are you getting now? Let's take a look at it. Doesn't look too bad. I think I get, that's 4. I'm sorry. Sorry about that. That's 9t4 plus 18t squared plus 9. Well, I'm going to factor a 9 out from that. So that would actually be the root of 9, which is 3. And then you get t4 plus 2t squared plus, I factor 3 out, right? That would be, I'm sorry, I factored 9 out. I'm sorry. That would have been a really tough one if that happened. Well, isn't that convenient? It's a perfect square. It's t squared plus 1. So I think I know this now. Let me write this down. 2, 0 to root 3, and the square root of that, only pull a 3 out, and the square root of that is going to be, I'm sorry, this is a perfect square, is t squared plus 1 dt. It's going to be 6. Antiderivative is going to be t cubed over 3 plus t. Limit of integration 0 to root 3. It's going to be 6. That's going to be 3 root 3. I'm cubing the square root of 3, by the way, over 3 plus root 3. And the lower limit evaluates to 0, but I'll write that down anyway. So what do you get over here? You get, let's see, that would be 2 root 3s, 12 root 3s. Now, barring any errors, I think I got it right, but always thinking is not a good thing. We want to verify. And we said 12 root 3s, right? Yep, 12 root 3s. We did okay. All right. Now, someone says, oh, they did it different here. They did different limits. But again, that could vary. Depends on what you're doing. I mean, they did something different than me. I just simply did one portion loop and doubled it. They did the entire loop in one shot. All right. So I'm going to go to the next question. And I want to make sure I understand what they're saying over here. And again, certainly I would like to look at the picture, because I'll be honest with you. You know what? Maybe don't look at the picture. It's the same picture, isn't it? Yeah, we got the picture right there. So I think I could start setting this thing up. So I think they say find the exact area of the surface obtained by rotating the curve about the x-axis from 0 to 1. Well, they give me the t. So this is going to be, I don't have to worry about the limits now between 0 and 1. Now, if I were doing that, I would like to visualize that. And I think I've already visualized the 0, right? It's right over here. Where would the function be at t equals 1? Now, by the way, I know where it is at root 3, but 1, where's it going to be? Well, I'm kind of looking at it. It would be what? It would be 3 minus 1, which is 2. And the y would be 3. So it'd be 2, 3. So I'm going to say maybe over here somewhere. So this is my arc they have over there. All right. But they want the surface area of revolution, and we're rotating about the x-axis. Is that true? Yep. Okay. Let's write this down. Let's put this down. I'm going to put this down. So my integration, right? So it's going to be surface area. And I can't remember in the notes what I used for surface area, but I think I used an uppercase letter S for that in the notes. I just really can't remember offhand. And what's it going to be? 2 pi. The limits of integration here are going to be 0 to 1, right? And then it's going to be, let's see, it's going to be the radius of that. And the radius of that is actually just y. It's the y value. Well, what's the y value? It's 3t squared times the arc length. All right. Did we just do the arc length? Yeah, I think so. What did it turn out to be? Really kind of simple, right? Turned out to be t squared plus 1 dt. So I don't want to do that again. Now, there's a chance of making a mistake over here, but let's go through it. What do you get over here? S equals 6 pi, 0 to 1. That's t4 plus t squared dt. Let's keep going. And again, S is going to be the surface area. 6 pi, that's going to be t5 over 5 plus t cubed over 3, 0 to 1. Let's write this down. Be careful. That's going to be 1/5 plus 1/3 minus 6 pi. With the lower limit, just evaluates to 0. So that's pretty simple. Let's put this down. 6 pi, 15. 3 plus 5 is 8. And I'm going to reduce. So 3 goes into 6 2 times, and it goes into this 5 times. So what he left off with, 16 pi over 5. Again, there's always a possibility for an error. So what I'd like to do is look at the key, and I made a mistake somewhere. And let me see where I made a mistake somewhere. I definitely made a mistake. And let's see where I made the mistake. You know what I made the mistake is? I copied the wrong thing from the surface area, and I apologize for that. Part of that just being completely sloppy about what I did over there. And if you remember, I simplified this thing, and I want to point out what I did was I should have copied this, and I didn't. I missed it. I missed the 3. So there's a 3 missing from this problem over here. And let me put that in for you. There's a 3 missing from this. And that was just poor copying skills from my end. All I was doing, looking at the past problem, and I forgot I pulled the CF from the integration. Let me put that in now. I'm correcting myself. This would become 18, 18, 18, 18. And let me see if I can do that. And 3 goes into, that's, let me just cross this out, put this down again. It's 18 pi. And this would be 8 over 15. I'm going to reduce by 3. This would be 5. This would be 6. 6 times 8 is 48 pi over 5. All right, let's go back and make sure we did that. And yeah, all right, sloppy copy. I probably shouldn't have copied them. The bottom line is, if you copy something, you might forget what you're copying, and I copied the wrong thing. All right, so it says find the area enclosed by. I think we've done that, but what I'm going to say is I would like to be able to visualize this. All right, and they, I don't, yeah, they do give me a visual. Let's take a look at it. And the visual is this thing over here. This is the visual. All right, so let's go back over here. And they want to find the area enclosed, the x-axis for this visual over here. All right, so I'm going to say, I know what they want me to do. And let me outline what they want me to do. They want me to find this area over here. And they add enclosed. And I'm going to shade that in for you. All right. An area is really going back to what you did in Math 121. But what I'd like to do is I'd like to, talk about the points here. All right. And what I know is I know the x in that case, looks around 2 and that looks like 3 point something. But more importantly, I think I know what the y is here. In both cases, I know the y is 0 in both cases. All right. So I'm going to write that down for you. It's right over here, by the way. So if y is equal to 0, what's t going to be equal to? Well, it's going to be t minus t squared. So t would be, let's say t, that would be 1 minus t. So the t could be 0 or the t could be 1. Let's find out what x is. If t is equal to 0, what would the x be? Well, that'll be 1 plus 1 is 2. Well, that seems reasonable. So this point over here is when t is equal to 0. And what's this point over here? Well, it's x, right? And what's the x equal to over here? Well, x is going to be 1 plus, and the t is 1 there, right? So the t is, this is where t is, this t is 1 now. Whoops, sorry about that. The t is 1 here. So what's the x going to be equal to 1 plus e? All right, I know this is tough. We're going to put down this over here. And I want to go through it step by step. All right, I'm not trying to memorize anything. So if I were to do this over here, what would I get over there? I'd get this over here is dx, and this over here is the height of it. All right. And what's the height of it? Well, I'm looking at the height of it would be y. Well, what's y equal to? Y is equal to what? Y is equal to t plus t squared. I'm sorry, t minus t squared. All right, let's write this down. All right, so let's put this over here. The area under that curve, I'm starting at 0 and I'm stopping at 1. The height of that is going to be t minus t squared times the dx. What's the dx? Let's write that down. The dx is equal et dt. Put that down. Et dt. I would consider this a milestone of the problem. So when you're doing homework, you want to see, did I get the milestone? Let's go back over here, and I want to point out what the milestone is. And the milestone is this guy right over here. I'm gonna just put this down over here. I'm gonna copy it. I'm gonna go to the next page and see if I met the milestone. Oops, sorry about that. Gee, I got the milestone. I didn't do the integration. I got to be honest with you. I don't think I'm terribly interested in doing the integration, but I'm going to go through it with you. All right. So to go through it with you, what I'm going to do is I have to, and it's a nightmare for me. I'll be honest with you. It's going to be t e to the t. It's doable though, I'll say that. Minus t squared e to the t dt. All right. And that's going to go from 0 to 1. Now, by the way, someone's going to say, how are you going to do that? I'm going to do it by integration by parts. I'll write this down for you. I want to do this one first. And I'm going to put this over here. So u is t, du is dt, dv is et dt, v is ET. Well, this one looks pretty easy to do. What do you get? T ET minus an integration ET dt. So this first guy looks pretty easy to do. Now let me write that down for you. So it's going to be T ET minus ET evaluated from 0 to 1. All right, let's do the next guy. This guy's done. Let's do the next guy. T squared ET dt. Let's write down. U equals T squared. I'm using integration on parts. Du is 2T dt. All right, you get the idea what I'm doing. Let's hope so. And then you're going to say dv equals et dt. So v would equal et. Well, let's write that down. So you can get t squared et minus 2t et dt. Well, you know what? We just did that. So let's write that down now. What are you going to get? T squared et minus 2. And I'll write it down for you. And what was it? It was t et minus et. All right, let me multiply that out for you. You get t squared, and it's tough. I'm not saying it's, I really, I don't even enjoy doing it. All right, let's put that down. All right, let's do our arithmetic. Let's see, the first one would give you what? Et minus et. I'm sorry, E1 minus E1 minus 0 minus 1. That was easy. Minus, let's do this one over here. This would be I'm sorry, E1 minus 2 E1 plus 2 E1. Let me make sure I did that right, by the way. 1 E1 minus 2 E1, 2 E1. Minus was plus. It's kind of big, isn't it? It's 0, 0, 2. Let's add it together. This disappears. This gives me 1. Let's see what we get. These disappear. You get minus a plus 2, which is 3 minus a. Let's see if we did it right. I'm going to look at the k, and we did. We got it right. So I'm going to say, you know, in my notes, I said I cheated. I used the Mathematica to do it. And it's true. Sometimes I get, you know, so tired, I don't want to do it. So I'm going to say, you know, we're kind of moving along, and I think I did some of the examples right. I did 1, I did 2, I did 3. Now I got to do problem number 4. All right. So let's write this down. And x is a function of t. That's going to be 3 sine 6t. And y is a function of t. That's 7 cosine of 6t. All right. They say, you know, approximate the distance traveled. Well, you know, find a particle speed. I think we've done that. Before I do that, I'm going to write a few things down over here. I'm going to write x prime down. And what's that going to be? 18 cosine 6t. I'm going to write down y prime for you. What's that going to be? Let's take a look. I guess that would be 6 times 7, right? So that's going to be 42 sine minus 42, I'm sorry, 6t. All right, so I guess I'll just do speed, right? So S prime, That's pretty simple to put down. We've done that before because they do want the particle speed. What's that going to be? Well, we gave you the formula and we derived it. And that's going to be, let's write this down. It's going to be x prime squared, 18 cosine 6t squared plus minus 42 sine 6t squared. And the speed at t equals pi over 24. So I'll write this over here. We'll look at the key later. This is a milestone, by the way. And let's write this down. So it's going to be 18 times the cosine of pi over 4, which is 1 over root 2. We need to square that. Plus, we're going to get minus 42. And that's going to be the sine of pi over 4, which is 1 over root 2. All right. I don't know if I want to do that arithmetic, to be honest with you. Let's go through it. 18 squared over 2 plus 42 squared over 2. I hate to do this to you, but I'm gonna try to do it. And again, I'm just trying to do the arithmetic. I want to see if I can get it. Let's see, it's 70 and 28, 98, right? 3, 18 and 98, 116, right? I don't know if I want to go further than that, but 116, right? 2 would give me 58. 2 into 58, so 2 times 2, 25, and 4, 29. Yeah, I can do it. 6 root 29. All right, I'm going to check. I hate to do that to you, but I'm kind of retentive on the arithmetic. And 6 root 29, right? Is that what I said? Yeah, 6 root 29. Miracle. Be able to do the arithmetic. All right. Remember, you can't do arithmetic. Don't do arithmetic. That's simple. All right. So let me see. I got the speed right. Approximate the distance traveled. I guess when they're saying approximate distance travel, I guess they want me to use a computer to do that. So I'm going to write the integral down, and then I'm going to use a computer to approximate. Now, someone says, what do you mean you're going to use a computer? When someone uses the word approximate, they're asking me to use a computer, but I got to write down what I'm going to do. I can't just ask the computer. I got to write it down. And this is going to be the length of arc, right? So what are we doing? Length of arc, and then give me the interval. I'll put this over here for you. Whoops, let's go back to black ink. And it's going to be from 0 to pi over 12. And I'm doing the distance traveled. And they want to approximate the distance traveled. They also want the displacement. We'll do that later. So what do we do over there? Well, I get the arc length, right? So let's put this down. I think I did some of the work already. And what did we call an arc length before? I think we called it in the notes. I think we called it L. It's going to be root. This will be dt over here. And then I'm going to put x prime down. 18 cosine 6t. You know what? I'm running out of room already. And I have to erase this. Sorry about that. It's going to happen to you on exams too. You erase or just cross out. Say, give me a new piece of paper. So L. And we're going from 0. Can't remember. Pi over 12. The root. And that's going to be 18 cosine 6t squared plus, that was minus 42, right? Minus 42 sine 6t. That whole thing is squared, and then dt. And I'm going to say this is, you do this on a computer. So do on a computer. Doing it by hand looks pretty damn difficult. I'm not saying impossible, but it just looks really difficult. So what I want to do is, did I meet the milestone? I didn't do it on a computer, by the way, but I want to see, did I meet the milestone? Did I get the right integral? And let's just simply copy that for you. And it's this thing over here. I'm going to copy it for you. Where's the arc length? So graph's not necessary to help. Oh yeah, it's right over here. What am I doing? You know what? I noticed my notes are losing some of their characteristics at this point. Oh, I see what happened. I must have copied something weird. So let me do that. I apologize for that. And let me copy. Let me go back. And I'm going to paste it in. I want to see if I met the milestone. I'm going to go to a computer algebra system in a second. And just give me a second to get this down. And I want to see if I got this. And I'm going to go through it one step at a time for you. And this is what we want you to do. This is what we're trying to teach you. Did I get the correct limits? Yes. Did I get the 18 cosine 6t squared? Yes. Did I get this one? Yes. What I did not is get the number. I am going to switch to my computer algebra system now. And again, I'm recommending you try this as well. And give me a moment. I just stopped that share. I got to start a new share with you. And let me point out where we are. I'm going to be doing this computation on a computer algebra system now. All right. And let's do that. Okay, I'm launching Sage now. And let me just clear the screen. I'm going to do reset. I'm going to say t is a variable. And then I'm going to type in the integration, integrate. Remember, if you make a mistake in Sage, it's not going to blow up or your machine shouldn't freeze or anything like that. So what I get over there, and again, it's not easy to type in, but I'll type it in 18 star cosine 6 star t. I think the biggest problem students have is actually typing in code. And we're going to square that plus, let's see, minus 42 star sine 6t. That's 6 star t. Again, I can't say there's no times you make a mistake, it's not going to blow up. Let's see if I did okay there. Yeah, let me close that out. And I'm going to say, you know, t is my variable, and I'm going to start at 0, and I'm going to stop at pi over 12. And I want to point out what happens here. Let's hope there's no error. But, you know, the bottom line is it returns back what a lot of people see as a really strange looking result there. All right. So I'm going to approximate the integral. So I'm going to say it had a tough time doing the integration. At least I believe it did. I want to try to force it to integrate. So I'm going to, you know, say numerical integrate. Now, I don't remember the command, but I see it right now. What did I do? I typed in NUMER, and then I see this numerical approximation. I'm going to do that for an integral, though. You see that? So I'm going to see if I can just type in the same exact thing without typing it in again. I'm just going to copy. And I don't know, maybe I can't do it. Oops, what happened there? Let's see what happened. You know what I'm going to do? Maybe I got the command wrong. question mark. It's going to give me a sample code. And let's see, interval algorithms. Let's take a look. Maximum points, 100. Let's take a look over. I'm just looking for an example. I see my problem. All right, I'm going to try it again. There it is. All right. So someone says, why couldn't you remember that? I don't use Sage all that often, to be honest with you. I really don't. But we're getting the correct number. Now, someone could say, I wonder what this thing is over here. My suspicion is an error bound on the problem. All right. There's an error. By the way, incredibly good approximation. All right. But what are you getting over here? We're getting the same number, 8.1714. Now, the other one I want to point out, also a computational problem. I just want to quickly go through it for you. And what I'm going to do is I'm going to define the functions now for you. And I'll go through how I would use a computer algebra system to do that. So I'm going to say, I'm going to define x as a function of t now. What's that function? It's going to be 3 star sine. Again, I'm using a computer algebra system for a reason, because you need to learn one. All right. You really do need to learn one. Now, someone says that I'd rather use my calculator or something else. Well, learn something. I mean, I'm not saying you have to learn this, but learn something. And I'm going to say y of t. And what's y of t? Y of t is going to be 7 star cosine 6t. And that's going to be 6 star t, right? Now, what's nice about having an answer key? Whoops, I made a mistake over there. I see the mistake already. I didn't put an equal sign in there. I'll just insert it now. I got this. Let me clear the screen. There's a lot of nonsense on the screen. And what I'm going to do now is I'm going to do the point. All right. Now, what I'm going to do is a distance formula. And what's this one going to be? Square root SQRT. And I'm going to do the change in the y's. So that's going to be y evaluated at pi divided by 12 minus, I'm doing a change in y's now, y evaluated at 0. I'm going to square it plus, now I'm going to do the change in x's. So it's going to be x evaluated at pi over 12 minus x evaluated at 0. Now, someone says, why use computer? They said approximate it. So I'm going to try to approximate it. Whoops, I forgot to square it. Now, certainly mistakes are going to happen. I make mistakes all the time. And it's one of the reasons we like to give you, what I call quality notes. You can make a judgment on that. But I want to see what happens over here. Whoops, I didn't even type it in right. Let's see where I went wrong in that one over there. And I got to be careful what I'm saying over here. I got to look at it again. Oh, I got another parentheses over there. Let's see if I did that right. I think I know I made a mistake here. I get dizzy looking at this stuff sometimes. Oh, square root of 58. I want to approximate that though, right? So I'm going to do this again. I'm going to say dot n. And let's see what happens. And I get that number over there. So I use a computer algebra system to do that. Again, you're free to use a calculator, anything you like. All right, let's see how we did though. Mistakes happen all the time. And I get it, 7.61577. I'm getting the same answer over there. All right, I realize this is a tough section of the notes for a lot of students. For one thing, there's formulas, right? I dislike formulas to no end, by the way, but there are formulas to remember for this or to derive. I would much rather have you come up with these formulas on your own, but at some point, that's just too much work on an exam. So have like a short list of things you can't remember before you take the exam. Make sure you know that you need to remember those things to take the exams. All right. So I think we did everything we need. And now certainly there's going to be some homework for you to do. All right. So hopefully that'll be something that you can handle on your own. If you do need assistance or help, please come by and I'll be more than happy to help you.